Ever wondered how data travels from one device to another? It's all about data communication. Picture this. You're sending a text message to a friend. The words you type are the message. You, or rather your device, is the sender. Your friend's device is the receiver. The data travels over a transmission medium, which could be a physical wire or a wireless signal. All of this is governed by a set of rules, or a protocol, which ensures that the message gets to the receiver in the correct format and at the right time. The combination of the transmission medium and the physical path through which data travels is known as the channel. Data communication is fundamental to the digital world we live in. It's the process that allows us to send emails, make phone calls, stream videos, and so much more. In essence, data communication is the invisible force that keeps our digital world spinning. Data can travel in different ways. Let's explore them. In the realm of data communication, there are three primary modes of transmission. First, we have the Simplex mode. Here, communication only moves in one direction. Think about television broadcasting. The station transmits the signals and your TV receives them, but your TV doesn't send any data back. Next, there's Half-Duplex. This mode allows data to flow in both directions, but not at the same time. It's like using walkie-talkies. When one person is talking, the other is listening, and then they switch roles. Lastly, we have the Full-Duplex mode. This mode enables simultaneous two-way communication. It's like having a telephone conversation where both parties can speak and listen at the same time. Each method has its place and purpose in different communication scenarios. Depending on the situation, different modes of data transmission come into play. Data can be sent as an analog or digital signal, and the choice between the two isn't a matter of preference, but depends largely on the nature of the data and the application at hand. Analog transmission, for instance, uses continuous signals to represent data. This type of transmission is akin to a flowing river, where water represents the data. However, this continuous flow can be susceptible to noise and distortion, somewhat like a river being disturbed by wind or rocks. On the other hand, digital transmission uses discrete signals, or in simpler terms, a series of zeros and ones to represent data. It's more like a train, where each carriage represents a bit of data. Digital signals are more resilient to noise, and they allow for error detection and correction, much like how a train can be easily controlled and monitored. Yet, each has its place. Analog transmission is often used in audio and video broadcasting, while digital transmission is the backbone of internet and telecommunications. Whether it's analog or digital, each type of data transmission has its place. Data doesn't travel alone, it needs a network. When we talk about data communication, we can't overlook the significance of networks. But what is a network, you might ask? In the simplest terms, a network is a collection of interconnected devices that share resources and communicate with each other. Let's delve a bit deeper into the different types of networks. First up is the Local Area Network, or LAN. This is a network that covers a small geographic area, like an office building or a university campus. It's like a small town where all the residents know each other and share resources. In data communication, LAN allows devices within a limited area to share data quickly and efficiently. Next, we have the Wide Area Network, or WAN. This is essentially a network of LANs spread over a larger geographic area. Think of it as a network of small towns connected by highways, allowing people and resources to move between them. In the world of data communication, a WAN might connect LANs in different cities or even countries, enabling data to travel vast distances. Lastly, we have the granddaddy of them all, the Internet. The Internet is a global network of interconnected computers and networks. It's like a bustling metropolis, connecting people and devices from all corners of the world. It uses standard protocols for communication, enabling data to move freely and efficiently across different networks. Each of these networks plays a crucial role in data communication. LANs are perfect for small-scale, high-speed data sharing. WANs enable data to travel across cities, countries, and continents. And the Internet, well, it's the ultimate data highway, connecting devices and networks globally. So the next time you send an email, stream a video, or browse the web, remember the networks that make it all possible. They are the unsung heroes of data communication, working tirelessly behind the scenes to ensure your data reaches its destination. Networks are the highways of data communication. Data needs rules to travel. Let's talk about protocols. When data embarks on its journey from one device to another, it doesn't just wing it. It follows a set of rules, a kind of digital roadmap known as communication protocols. Picture it like traffic laws that help cars navigate from point A to point B without crashing into each other. Communication protocols perform a similar function, ensuring that data reaches its destination correctly and efficiently. So what are these protocols that play such a pivotal role in data communication? The first one we'll look at is the Transmission Control Protocol, or TCP, coupled with the Internet Protocol, known as IP. Together, forming the TCP/IP protocol suite, they lay the foundation for the Internet as we know it. TCP is like a reliable courier, ensuring that data packets reach their destination without getting lost or damaged. IP, on the other hand, is like a GPS, determining the best route for these packets to take. Next up, we have the Hypertext Transfer Protocol, or HTTP. HTTP is like the lingua franca of the World Wide Web, responsible for transmitting hypermedia documents such as web pages. When you type a URL into your browser, HTTP gets to work, retrieving the web page and delivering it to your screen. Finally, we have the File Transfer Protocol, or FTP. As the name suggests, FTP is all about transferring files between computers on a network. Whether you're downloading a software update or uploading a photo to social media, chances are FTP is working behind the scenes to make it happen. Each of these protocols plays a unique role in data communication, ensuring that data gets where it needs to go in the format it needs to be. They're like the unsung heroes of the digital world, quietly making sure everything runs smoothly. With the right protocols, data travels smoothly and securely. And that, in a nutshell, is the magic of communication protocols. No wires, no problem. Welcome to wireless communication. This revolution in data communication has done away with the need for physical connections, enabling data transfer over the air. So how does this magic happen? Wi-Fi, a familiar name in most households and cafes, allows devices to connect to a local area network. It's like an invisible cord, connecting your device to the internet, providing you with the latest news or that favorite movie of yours. Then there's Bluetooth, a short-range wireless technology. It's the invisible handshake between your smartphone and your wireless headphones or the car's audio system. It's all about convenience and clutter-free connections. And let's not forget mobile communication. Our phones, tablets, even watches constantly chirping with messages and updates, all thanks to cellular networks. They've transformed our devices into global communication hubs. So whether it's Wi-Fi, Bluetooth, or mobile communication, these wireless technologies are making data travel not just possible, but easy and convenient. Wireless communication makes data travel easy and convenient. Data needs protection during its journey. Let's talk about security. In data communication, security is not just an option, it's a necessity. As we send and receive data, it travels through various channels, potentially exposing it to threats and unauthorized access. The safeguarding of this data during its journey is an integral part of data communication. To secure our data, we use a method called cryptography. Picture this. You're sending a secret message in a bottle across the ocean. You wouldn't want just anyone to be able to read it, right? Cryptography works similarly. It's like a secret language that only the sender and receiver can understand. The data is converted into an unreadable format, often called ciphertext. This process is known as encryption. Only those with the appropriate key can decrypt or translate the data back into its original form. This ensures that even if the data falls into the wrong hands during its journey, it remains gibberish without the correct key. But how do we protect our data from even reaching those wrong hands in the first place? Enter firewalls and security protocols. A firewall acts as a gatekeeper between our network and the outside world. Like a bouncer at a posh club, it only allows authorized data to pass through while blocking potentially harmful data. On the other hand, security protocols are like the rules of the club. They define how data should be packaged, transmitted and received to ensure a secure communication process. In essence, cryptography, firewalls and security protocols work hand in hand to create a secure environment for our data. Cryptography ensures our data remains unreadable to unauthorized parties. Firewalls prevent unwanted data from infiltrating our network, and security protocols guide the secure transmission and reception of data. Data communication is not just about sending and receiving information, It's about doing so safely and securely. With the increasing digitalization of our world, the importance of secure data communication continues to grow. Secure data communication is a must in our digital world. Data communication is everywhere. It's in every device you use. From the message you send to the receiver, along the transmission medium, and through the protocols and channels, data is constantly in motion. It travels in various modes and forms, either as analog or digital signals. Networks, be it local or wide area ones, or even the global internet, are the veins through which this data flows. Protocols like TCP/IP, HTTP, and FTP are the conductors, ensuring this flow is smooth and orderly. And with wireless technology, this communication is no longer bound by physical constraints. But remember, as we embrace this convenience, we must also safeguard our data with cryptography, firewalls, and secure protocols. Data communication is the lifeblood of our interconnected world. It's essential, it's fascinating, and it's continually evolving. The next time you send a message or browse the internet, remember the journey your data takes.